Sometimes the simplest things hold the biggest secrets. This little square, for instance, looks pretty basic, but it's actually an ancient puzzle with the power to unlock a really deep and modern understanding of math. Today, we're going to see exactly how.
I bet you've seen something like this before, right? This little cat figure. It looks like a simple kid's toy. But what if I told you that inside these 7 little pieces is a journey that takes you from basic geometry all the way to formal proofs? Let's break it down.
And, believe it or not, this entire universe of ideas, it all starts with one simple, powerful shape, the square.
So this puzzle? It's called a tangram. It's ancient, and its genius is just how simple it is. Seriously, you take one square, make a few very specific cuts, and boom, you've got 7 flat shapes. They're called tans. And that's it. That's your entire toolkit.
Now, these pieces aren't just random, okay? They're born from these super precise cuts that connect the midpoints of the square. And that's how you get the full set. 2 big triangles, 1 medium one, 2 little ones, a square, and a parallelogram. The really cool part? Every single piece is mathematically related to all the others from the get-go. And from there, oh man, the sky's the limit. The goal is super simple. Just use all 7 pieces, no overlapping, and make a picture, a silhouette. You can make cats, dogs, birds, you name it. There are literally hundreds of designs. It's part art project, part brain teaser.
But, it's way more than just making cool shapes. This is where the puzzle really starts to shine as a tool for unlocking all these different levels of mathematical thinking.
And this is the key thing to get. A tangram isn't just a toy to kill time. It's like a hands-on toolkit for exploring math. You get to actually feel and see the concepts, which takes you on this incredible journey from just playing with shapes to building some really complex, solid proofs. Honestly, the best way to think about it is like leveling up in a video game. Level 1 is just visualization. You're playing, sorting the pieces, making pictures. Then you hit level 2, analysis. You start getting curious, right? What about the angles? How do the areas compare? And then you get to the final boss, level 3, deduction. That's where you can actually prove all those cool relationships between the pieces.
All right, you ready? Let's try a level 2 question together. Just by looking at the pieces, how could you prove, without any formulas, just the shapes themselves, that the parallelogram and the medium-sized triangle have the exact same area? Take a second, think about it.
Okay, you got it? Check this out. It's so brilliant. If you take 2 of the small triangles, you can arrange them to make the parallelogram. But wait, you can also arrange those same 2 small triangles to make the medium triangle. So, since they're both built from the exact same 2 base units, their areas have to be the same. See? No formulas needed, just clever thinking.
All right, ready to level up again? Level 3. How can we prove for sure that the small square and the parallelogram have the same area? This one takes a little more brain power.
And here it is. The proof is actually right in front of us. Just like we did before, let's use that small triangle as our little measuring stick. The green square, it's made of 2 of those small triangles. And the pink parallelogram? Yep, you guessed it. It's also made of 2 of them. So, their areas have to be equal. It's so elegant, isn't it? It's visual, and the logic is just solid.
Okay, so everything we've talked about so far has been in a flat, 2-dimensional world. But what happens when we decide to break out of that?
Yeah, we've been stuck on a flat plane this whole time, but the real world isn't flat. It has depth. So what if we gave our tangram pieces a 3rd dimension?
Well, you go from these flat little tans to solid 3D blocks. You basically just extrude the shapes. The square piece becomes a cube, the triangles become wedges, and all of a sudden you have a whole new universe of properties to explore.
And this one simple change just explodes the mathematical vocabulary. We're not just talking about area anymore. Now we're talking about volume, surface area. We can count the faces, the vertices, the edges on every piece. The puzzle literally evolves right in front of you.
And you know what? It doesn't even stop there. This core idea of dissecting a shape into smaller parts, you can apply that to so much more than just a square.
For example, look at this, the heart tangram. It's just beautiful, isn't it? But it's not just a random design. It's grounded in pure geometry. It starts with a square. You add 2 semicircles, and then you dissect that shape into these really unique pieces with curves and straight edges.
And what you get is this absolutely gorgeous puzzle. It looks like a piece of art, but it still has all that mathematical DNA baked right in. It's such a great reminder that a lot of the time, logic and beauty are really just two sides of the same coin.
I love this part. The creators even left this charming little rhyme to go with it. Let's see. Heart shapes here, heart shapes there, put them together with some care. Squares and circles, take a peek, together make the heart we seek. How cool is that? It just perfectly captures that playful exploratory spirit.
So when you look at all of this, the classic square, the 3D blocks, this beautiful heart, what's the big idea? Well, it really all boils down to the genius of simple play.
And that's really the main takeaway here. The Tangram is a perfect example of how there's so much complexity, so much beauty, just waiting to be found in simple ideas. All we have to do is let ourselves be curious, let ourselves play, and just look a little closer.
And this is why tools like this are so incredibly important. They prove that elementary math doesn't have to be about boring drills and memorization. It can be this fascinating, hands-on adventure. It turns out that simple things, when we get creative with them, can help us, and especially kids, understand what math is really all about.
So, as we finish up, I want to leave you with a question to chew on. Now that you've seen the entire universe hidden inside this one little puzzle, what's a simple toy, or even just an everyday object, that you're going to look at differently? What hidden complexity out there are you ready to discover?